Yeah, good evening all. Welcome to TCS NQT 2026 coding training day 3. Welcome to TCS. Hope audio is clear. Is my audio clear to you? Okay, thank you. So today we will solve uh, remaining questions which were asked on March 15th, 2025 examination. Let me share the screen to you. So this is question number 3 which was asked in second shift. March 15, 2025, 2025 examination. So let's go through the problem statement. Okay, so here the problem is make three numbers equal. So this is the problem heading given. Okay, so you should make the three numbers equal. So the statement, problem statement, if you read, you are given three integers p, q, and r. Okay, so here p, q, r are three integers given to us. So you can perform the following operations any number of times. This we should underline. Remember this. Okay. So what operations? The first one is select any two numbers and increase both by 1. We should increase those two numbers which we selected. Okay. Out of these three numbers, and we should increase those two numbers by 1. This is first operation you can perform. Then decrease the third number by 1. Then the remaining number, the third number, we should decrease by 1. Okay, so these two operations, operation 1 and 2, you can perform on these three numbers p, q, and r any number of times, and see that finally the numbers become equal. Got it? So example here. So what is our task we will see here. So your task is to determine the minimum number of operations required to make all the three numbers equal. Okay. So initially the three numbers are different. Okay. So you should make them equal by performing these two operations. And how many such a number of operations, minimum number of operations are required. Okay, so to make all the three numbers equal. Example, if you consider, okay, so the input is given like this. So here the first number, okay, so on the input indicates the number of test cases. Okay, so this indicates the number of test cases. Then followed by the four inputs. Okay, so we are given three numbers, we said, no? So those three numbers for each test case, they are given like this. Okay, so this indicates test case number 1. This is set test case number 2. This is test case number 3. This is test case number 4. Okay, so your code should run against all these test cases. Okay, and for each test case, the output is given as -1, 0, -1, and 3. Okay, so we need to find out this output. Okay, so first let us work out output for the first test case. Okay, so 1, 2, 3. So these are the three numbers given P, Q, and R to us. Okay, right? So what you can do, you can select any two numbers and increase both by 1. Then decrease the third number by 1. Okay, so then you will have three options. Okay, so you will have three possibilities here. Okay, so the first possibility is you can increase, say for example, P, Q, R. Okay, so what you can do is you can increase this P and Q by 1, and then you can decrease R by 1. Okay, so if you perform this, this is the first possibility. Okay, so to perform this, what is the output you will get? What are the, how the numbers changed here? Okay, so P will become 2 here. Okay, so Q will become 3 here. Then R will become 2 here. This is first possibility. Then the second possibility is you can increase P by 1. Okay, then R by 1, then decrease Q by 1. So if you do this, what you will get here? P will become 2. Okay, so Q will become 1. Then R will become 4. R will become 4. Okay, then the third possibility is what you can do is you can decrement P. Okay, then you can increment Q and R by 1. Then if you do this, okay, so P will become 0, Q will become 3, and R will become 4. Okay, so in this, if you observe, okay, so the value of a number should not be more than the maximum value of the given input. Okay, so always, because if you want to make them equal, okay, so you should increasing some numbers, and ultimately the maximum number and minimum number should come close to each other. Okay, so if they want to, that means the maximum number should reach close to minimum number. Okay, so that means it should not be more than the maximum value of this. Okay, so in this output, now see, one of the variable R reaches to 4, and here also it reaches to 4. Okay, so these two possibilities you can wipe out. Okay, so these two possibilities are not important, or they cannot be used for finding the number of operations which make them equal. Okay, so these cannot be used for our purpose. Okay, so the left is this one. Okay, so again, if you perform the same kind of operations, again for this you will have three possibilities. Okay, so like this you should go on finding. How long you should do this? How long you should do this? Okay, so if you start working like this, you never end up with some solution. Okay, so what you need to do is first you need to observe the numbers. Okay, so the numbers are 1, 2, and 3. Okay, so ultimately what is given? All the numbers should become equal. All the numbers should become equal. Okay, so become equal means, say for example, all of them may become equal. Okay, so assume that by some operations, if all of them are made equal as a 2, 2, 2. Okay, so then what is their sum? If you perform this, then their sum will be 2 plus 2 plus 2. Okay, so this is nothing but 6. 6 you are getting. Okay, so which can be written as a 3 multiplied by 2. Okay, so that means all are equal, no? All are equal. Equal means here the target value should be 2 here, and this should appear 3 times. It should appear how many times? 3 times, because all of them are equal. Okay, and this becomes our target value. This becomes our target value. That means finally all the values should become 2. Okay, so then 3 into 2, then this becomes 6 here. Okay, so the total sum, okay, so this whatever total sum, once they become equal, okay, so then the total sum, their sum should be a multiple of 3. Okay, it should be a multiple of 3. Yes or no? If all of them are equal, okay, so it should be a multiple of 3. Like see here. Okay, so 6 is a multiple of 3. The total sum, okay, so should be equal to multiple of 3. Okay, so 6 can be. Assume that, okay, so all the numbers became 3, 3, 3. Okay, so then what happens here? Total sum means 3 plus 3 plus 3. It becomes 9, which is a multiple of 3. That means you can write it as multiple 3 times of some number. Okay, so assume that 3 times of some number x, some target value x. It can be written as 3 times of some target value x here. Okay, so here x is the target value. Okay, so this x is nothing but 3 here. Okay, so this 3 here. That means all of them should become 3, 3, 3. Then only it becomes a 9. Okay, so then which is 3 times the target value. Okay, so the first observation made from this is, if the 3 numbers should be equal. Okay, so I am just writing here. The first observation is, if the 3 numbers should be equal, if 3 numbers are equal, okay, so equal, so then what happens? Their total sum, okay, so should be equal to some 3 times, okay, a target value x, 3 times a target value x. Okay, so this x we need to determine here. You take any combination of these numbers. Okay, so it is nothing but 3 times a target value x. Okay, so it should be a multiple of 3. The meaning is their total sum should be a multiple of 3. This is one observation made. Okay, so if you can make this, then only it is possible to make these 3 numbers equal. Okay, so this is one observation. Got it? Then the second observation what we need to do in such kind of problems is, okay, so you should observe their parity. You should check their parity. Okay, so parity means whether they are even or odd. All the numbers are even or odd. Okay, so this observation you should make in such kind of problems, remember. Okay, so parity check you should do. Okay, so what happens if all the numbers becomes equal? All the numbers becomes equal, what happens? How the parity changes? Okay, so we need to understand this. For example, if all the numbers or equal. Okay, so let me just take this example 117. Okay, because for this 117, so the number of operations are 3. Okay, so by making these three operations, all the three numbers becomes equal. Okay, so how they become equal, first I will write here, then we will see here. Okay, so operation 1, see here, in first operation what I am doing is I am incrementing these two values. I am incrementing these two values. Okay, so plus 1 here, plus 1 here, then I am decrementing this. So what is the new one I will get here? 2, 2 and 6 I will get. This is my first operation. Okay, then in the second operation, okay, so what I can do, I can increment the first two values, then I can decrement the third value. Okay, so then I'll get 3, 3, 5 here. Okay, then in operation 3, what I can do, I can increment these two values. Okay, then I can decrement the third value. Then I'll get 4, 4 and 4. Now all the three numbers becomes equal here. Okay, so that means how many operations I did? 3 operations I did. Okay, so that's why the answer is 3. The answer is 3 here. Okay, now, so given a combination like this, given a combination, okay, so you have arrived at this combination. All numbers you made equal. Okay, so first you need to decide whether is it possible for a given combination of numbers to make them equal or not. Okay, so this you can decide by using the parity check, by performing the parity check here. Okay, so parity check means initially, now see here, what is this number? This is odd number. Okay, this is odd number, this is also odd number. Okay, that means all the three numbers are odd initially. Okay, so then finally if they are equal, what happened? All the three numbers became even. Okay, so that means from odd parity they all have changed to even parity. If all the numbers have odd parity, okay, so then it is possible. Okay, once the numbers becomes equal, then their parity changes to even parity. This is one test case. Got it? Okay, so for example, if we take a even parity numbers, okay, so even parity number, initially if we take even parity numbers, then we need to test whether is it possible or not. Okay, now what are the two operations given here? These two operations, how they changes the parity, that also we should consider here, how they changes the parity. Okay, so you are incrementing the two numbers and decrementing the third number. Yes or no? Incrementing two numbers and decrementing the third number. Okay, so initially if the numbers are odd parity, if the numbers are odd parity, okay, so if you perform this operation, okay, so then their parity changes to even. That means if number is odd, by adding one or decrementing one, okay, so we'll change its parity. If the number is even, see here, if the number is even, okay, so then adding one and adding one and decrementing one changes their parity. Okay, so that means here from odd parity they changes to even parity, they changes to odd parity. Okay, it's just like flip. Okay, so even changes to odd, odd changes to flip, because you are either incrementing by one or decrementing by one. Okay, so it's just like a flip operation. Okay, so even parity changes to odd parity. Okay, so that means initially if all the numbers are with odd parity, okay, then they changes to even parity. Then only it is possible that the three numbers becomes equal. Initially if all the numbers are with even parity, okay, so they may change to odd parity, all of them change to odd parity. Okay, then only it is possible to make them equal. Okay, so if they have with different parities, then it is not possible. Okay, like the one given in the first test case, 1 2 3. Okay, so 1 2 3, if you consider, this is odd parity, this is even, and this is also odd number. Okay, so if you add 1 to this, it changes to even. Okay, so if you add 1, it changes to odd, and if you decrement 1, it changes to even parity. Okay, so that means they never become equal in their parity if they have different parities initially. This is the second observation to be made. From the examples you can consider, say 3 to 6. Okay, third example if you take a, okay, so 3 to 6, that also you can see here, 3 to 6. Okay, so this is odd, this is even, this is even. So if you increment or decrement, okay, so if you increment the first two, this parity changes to even, this parity changes to odd, and this parity changes to odd. Okay, so they never become equal. Okay, so if all the numbers should become equal, means all of them should have either even parity, or all of them should have odd parity. Okay, but by adding one or decrementing one will flip the parity. Okay, so with different parities, they never come to this state. It is not possible. Okay, so that is the first check you can perform to decide whether is it possible to convert these numbers, to make these numbers equal or not. This is the most important observation to be made in these kind of problems. Parity check, we call it as a parity check. Got it? Any doubt in this, you can just type in the chat. If you have any combination which violates this rule, you can just type that test case in the chat, we will discuss. Got it? Okay. So what is the first condition to be tested? Parity check you need to do. Okay. So parity check you should do. What is the parity check? All the numbers. Okay. So all of them should have even parity or odd parity. All the numbers should have either even parity or odd parity. Then only you can make them equal. Okay. So if this parity is not followed immediately from the given input, now see, you can print -1 as output. Okay, so since the first two is 1 and 3, okay, so have different parities. Okay, 1 2 3, 3 to 6. Let us see here, 1 2 3, see, odd even odd. Okay, so it is not possible, you these numbers never become equal. Okay, 3 to 6 also, these numbers never become equal. Okay, so that's why for these cases directly you can return -1. Now coming to the second test case, it is 4 4 4. Okay, so that means the numbers are already equal. Okay, so if the numbers are already equal, then you should return a, because you cannot make any more operations, you cannot perform any more operations. Okay, the number of operations performed are 0. Okay, so that's why the output is 0 for the second test case. Okay, now coming to the last test case, 1 1 4. Okay, so as we have seen, for this 1 1 4, the number of operations that can be performed are 3 here. By performing these 3 operations, finally they become equal. Okay, got it? I'll give you one more test case, okay, even though it is not mentioned here. Okay, so let us take one another test case where we have all even numbers, and we will see whether it is possible or not. Okay, so for example, if you have a combination like 2 6 and 12. 2, 6 and 12. Okay. So the very first thing is whether can we make them equal or not. Okay. So the first condition to be tested is parity check. Okay. So parity check means the first number is even number, second number is also even number. Okay. Third number is also even number. Okay. So that means all of them are even. Okay. So parity check passed. If they have different parity, one even, one odd, one odd, odd, okay, so then they never become equal. Directly you can output -1. Okay, so first parity check passed. All of them are even, even, even parity. Okay, right. So now it is confirmed that okay, so you can make them equal. You can make them equal. Okay, so first manually we'll try to mathematically we'll try to make them equal. Then we'll see how many operations are required. Okay, so first operation 1. Okay, so what I do is I increment this by 1, I increment this by 1, then I decrement this by 1. So this becomes a 3, 7 and 11. Okay, so in the second operation, what I do is I increment this by 1, I increment this by 1, I decrement this by 1. So this becomes a 4, 6 and 10. Sorry, 8. This is increment, no? It becomes 8. 4, 8 and 10. Okay. So next operation 3. I increment this by 1. I increment this by 1. Then I decrement this by 1. Okay. So then this becomes 5, 9 and 9. Okay. Then operation 4. I increment this by 1. Okay. Then I increment this by 1. Then I decrement this by 1. So this becomes 6, 10 and 8. Okay. Then operation 5. Operation 5. Okay. So what I do is I increment this by 1. Okay. Then I increment this by 1. Then I decrement this by 1. Okay. So this becomes 7, 11 and this becomes a 7. Okay. So then in operation 6, what I do is, okay, so I increment this by 1. Okay. Then now what I do is I decrement this by 1. Then I increment this by 1. You can select any two numbers. Okay. In the question it is given that select any two numbers. You can select any two numbers. Okay. So I increment the first and last now, decrement the middle one. Okay. So this becomes a 10 and this becomes a 8. Okay. So then in operation 7, I increment this by 1. I increment this by 1. Then I decrement this by 1. Okay. So then this becomes a 9. This becomes 9. This becomes a 9. Okay. So now all of them are made equal. So total how many operations I performed? Okay. So total 7 operations I performed. Okay. Now with given even parity, see here initially they have even parity, even, even, even. Okay. So and finally, if it is possible to make them equal, their parity becomes a odd parity. Okay, so that's why parity check is very, very important. Manually, we should work out this for half an hour, 30 to 40 minutes. And do such observations. Okay, so this is manual calculation. Okay, then how to arrive at this number 7? How to arrive at this number? How to know that only 7 operations are required for this? Okay, so for this what we require is, okay, so now let us understand the gap. Okay, so we need to go on reducing the gap, or you can also call it as a distance. Okay, so distance, what distance between small number and large number. Okay, so you should go on reduce the distance between smallest number and the largest number, then only you can make them come closer or equal, you can make them equal. Okay, so this gap you should go on reduce. Okay, so in each operation how much gap is reduced, that we should understand, okay, so here if we take the previous example, I'll take 117 example and we will see here. Okay, so I'm just taking here 1 1, then I'm taking a 7 here. Okay, now in the operation 1, in first operation what we are doing, we are incrementing this by 1, we are incrementing this by 1, then we are decrementing this by 1. Okay, so that it becomes a 6, it becomes a 6. Okay, so initially, now what is the maximum value? 7 minus 1. So what is the gap between maximum and minimum? It is 6 units, just you can say 6 units, 6 meters, you can just say. Okay, right, so now this is the gap between them, this is the gap between them. Okay, so it is 6 units, initially it is 6 units, the difference is 6 units. Now after performing one operation, okay, so how much gap is reduced, how many units of gap is reduced? Now see here, the number came up to this part and this number came up to this part. Okay, that means it is increased by 1, it is decreased by 1, means here it is decreased by 1. Okay, the gap is reduced, 1 unit reduced here, 1 unit, so total 2 units of gap is reduced in one operation, 2 units of gap is reduced. Okay, so after one operation, now you can see this becomes the largest number and this becomes the smallest number. Okay, so then now if you see 6 minus 2, now it is 4, you can confirm 6 minus 4 is 2. How many units? In each operation 2 units of gap is being reduced. Okay, so here like this, that means in one operation, okay, in one operation 2 units of gap is reduced. Okay, so in other way you can write this, 2 units of gap is reduced in one operation. Okay, so then how many units of gap, how many such operations are required? Okay, so how many operations are required to make them equal? Getting or not? Okay, so like this, if this question you should require, so that these units, okay, so they become equal, how many such operations are required here, so that the numbers become equal. Okay, so here one operation you did this. Okay, so like this, if you increment this, now see it becomes 3 here, it becomes 3 here, operation 2 here. Okay, and this becomes a 5 here. Okay, so 6 minus 2, 4, the gap reduced now. Okay, so after this second operation, now the gap is reduced, like 5 minus 3. Okay, it became 2, it became 2, 2 units, every time 2 units of gap you are reducing. Okay, so after this again one more operation, if you perform operation 3, this becomes 4 and this becomes 4 and this also becomes 4. Now all of them are equal or on the same line now. Okay, so the gap between 4 minus 4 is 0, that means you made them equal. So here the observation is, in one operation, okay, so you are reducing the gap by 2 units. You are reducing the gap by 2 units. Okay. So then how many such operations are required? See, in these kind of problem, generally where we make mistake is given a number. Okay. Given a number, we should only find out how many operations are required. We don't want what are the final numbers that are equal. Okay, so what we do is we try to calculate this kind of answer here. Okay, so for this what we do is, if this is given and finally we arrive at this after three operations. Okay, so students generally make mistake or waste their time by calculating these final answer. Okay, this 444 is not required for us. 444 is not required for us. Okay, or this 999 is not required. Given this input, how many operations are you are doing? Seven operations you are doing. Seven operations you are performing. Okay, so only this seven we require. Okay, in this case only this three we required. We don't want what is the final number that are equal. Got it? Okay. Right. Now, how to arrive at this number of operations without doing all these calculations? Otherwise, you need to write lot of code for this. Okay. So, which is not required. The simple way you need to find out number of operations. Okay. How you can find out number of operations here? Okay. Now, if you understand this, okay. Now, what we do is we can try to solve this mathematically. Okay, so hope you got this. In one operation we are trying to reduce 2 units of gap. Okay, so if you go on reduce the gap, then only all of them becomes equal. Okay, so how many such operations are required? This is what you need to calculate to make this gap as a 0. Okay, right now, so if you observe this, okay, right, so what we can do is, say for example, if given number s is their initial sum. Okay, so their initial sum is something like a we'll take this one only. What is this? 117 example we will take. Okay, so I will write here 117. Okay, so what is the initial sum? Initial sum is 1 plus 1 plus 7. Okay, so 1 plus 1 plus 7. So what is their initial sum? It is 9. Okay, first thing, the very first thing is parity check you need to perform. So if it passes parity check, then you need to find out the number of operations. Okay, so assume that the parity check passed. Okay, so then we are trying to find out the second one, number of operations we will try to find out for this. Okay, so how to calculate number of operations? Just see here, see the observation. Now initially for the given numbers their sum is 9. Okay, so if they become equal, okay, so what is the total sum we are getting of when they become equal? It is 4 plus 4 plus 4. Okay, so which is nothing but 2, which you can write as a, okay, so multiple of 3. Okay, so it is nothing but 3 3. Okay, so times some target value. Okay, so it can be written as a 3 times some target value. Okay, so here this x can be written like 3 times 4. 3 times 4. Okay, so 3 times 4, that means if this is the given this numbers, okay, so their final sum, if they become equal, their final sum should be a multiple of some target value x. Their final sum should be a multiple of a, okay, 3 multiple of a target value. It should be a 3 multiple of their total sum. Okay, so the total sum should be equal to 3 times a target value. Okay, so here the target value in this case from this example, since we have solved, okay, so it is 4. It is 4. Okay, so that means all of them become equal at 444. That is what you can arrive at this. Okay, but this is not known to us. Since we have solved, I want just show you here. Okay, so we want to arrive at we want to solve this x value, we want to find out. Okay, so this is how you should think. That means if initially given the three numbers, if they become equal, their total sum should be, okay, so it is a 3 multiple of some target value. It is always 3 multiple of some target value. For example, if the three numbers becomes equal to something like 666, okay, so how much you will get? 18, which is nothing but 3 multiple of some target value. That means it is a 3 multiple of some certain target value. If they become equal to 777, 21, it is a 3 multiple of some target value. So in our case, see, 999 we got here. Okay, so we got 999. Okay, so it is nothing but a 27, which can be written as 3 multiple of some target value. This target value, x value, is 9 here. Okay, this x indicates that what is that number where they become equal. Got it? Okay, so this we need to find out. This we need to find out mathematically. Okay, so how we can arrive at this? Now observe here. Right. Okay, so that means their initial sum. Okay, so initial sum is 9. Okay, so please observe carefully here. Initial sum is initially 9, and their final total sum is equal to 12. Their final total sum is equal to 12. Okay, once they become equal. Okay, so this is n and this is some total sum. Assume that when once they become equal, their total sum is 12. Okay, so that means what happens to this initial sum? What happens to this sum to make it equal to 12 in each operation? In each operation, okay, so what happens to this initial sum? Okay, so let us find out this. For example, 117 here. Okay, so what you are doing, you are incrementing these two numbers by 1. You are incrementing these two numbers by 1. Okay, so that means to the initial sum, okay, I'll tell you, then you are decrementing this by 1. It becomes a 6 here. It becomes a 6 here. Okay, so then what is the new value you are getting here? 6 plus 2, 8. 8 plus 2, 10. Okay, that means after one operation, you are getting the sum of those numbers as a 10. Okay, so that means what is happening? That means the initial sum after one operation is increasing by 1. Yes or no? Okay, because two plus operations you are performing and one minus operation you are performing. Okay, so it is nothing but 2 minus 1. Two times you are incrementing, one time you are decrementing. Okay, so that means to the previous values, 2 minus 1 means just you are adding 1 extra to the total sum. Yes or no? You are adding extra 1 to the total sum. That means every time the initial sum will be incremented by 1 by performing those two operations. Yes or no? Will you accept this? Understand the concept carefully here. Okay. So for the initial sum, okay, if you perform increment two numbers and decrement another number, okay, so how much you are adding to the total sum? The new combination of values, this is the new combination of values, the sum becomes 10. That means it becomes 10 here, incremented. That means initial sum incremented by 1. Now we'll observe one more observation. We increment this by 1, we increment this by 1, and we decrement this by 1. So what is the total value you get here? It is nothing but 5 plus 3, 8, 8 plus 3, 11. So in the next operation, see here, the sum is incremented by 1. So that means in one operation, your initial sum will be incremented by 1 only. Okay, now see here. So initially your sum is 9, and you want to make this sum to 12. You want to make this sum to 12. Okay, by performing some number of operations. Okay, so how each in each operation only one will be incremented. Okay, so that means how many such number of operations if you perform, how many such number of operations if you perform, okay, then the 9 becomes equal to 12. 9 becomes equal to 12. Okay, that means in three operations, okay, so the 9 becomes equal to 12. Yes or no? See here, 9 became 10, 10 became 11. After this, now see, this becomes 4, this becomes 4, this becomes 4. Okay, so now the total is 12. So how many operations you performed here? This is 1, this is 2, this is 3. Okay, so it is as simple as that. Initial sum you calculate. Okay, so to initial sum, okay, so then if you perform three operations here, okay, so the n indicates number of operations. If you perform three operations, then don't worry about this total sum, then the numbers become equal. The numbers become equal. Okay, so it is, the formula can be write this: s plus n should be equal to total sum. S plus n should be equal to total sum. Okay, so this n you need to calculate here. Okay, this n you need to calculate here. Since the example is given, from solved example we arrived at this 3 here. Okay, so given a new combination, how to identify this n value? Okay, so let us work out that. Let us work out this. Okay, so slowly we are making the problem simple. Getting or not? Okay, right, now see here, so given a new combination of values, okay, for example 2 6 12 we will take and we'll arrive at the solution. Okay, so we'll take this 2 6 12. Okay, so I am just writing here, so 2 6 12, 2 6 12. Okay, or from this example you can understand easily, or 117. Okay, so if this is p, this is q, and this is r. Okay, this is r. Okay, so the number of operations that are required, okay, so what you need to do is, you need to make the smallest number. Okay, this is the smallest number, no? Okay, so this smallest number, okay, so you should go on reduce distance with the other two numbers. You should go on, okay, distance with the other two numbers. Okay, so then only it becomes the three numbers becomes equal. Okay, right, so how you can arrive at this, you can see here. Okay, so shall we take this example or this example? Any one example you can consider here. Okay, now so first let us find out the distance first distance between first two numbers. Okay, first two numbers I am trying to find out the distance between first two numbers. Okay, so what is the distance here? 6 minus 2. The distance between first two numbers is 4. Okay, then I'll find out the distance between first and last number. Okay, so it is 12 minus 2, which is equal to 10 here, which is equal to 10. Okay, so that means what is the total distance this first number has with other two numbers? The first number has with other two numbers. Okay, so it is nothing but 4 plus 10. 4 plus 10. Okay, right, so that means the first number has a distance of 4 units with second number, and it has a distance of 10 units with the third number. Okay, that means the first number has total distance of 14 units between these two numbers. Okay, so if it has become equal to other two numbers. Okay, so this is the total distance. This is the total distance. Okay, so then divide this total distance by 2. I take average of these two. Okay, so that gives this. Okay, so why 2 here? Why 2? Because in each operation you are reducing the distance by 2 units. You are reducing the distance by 2 units. If the total distance is 14 units, now see, if the total distance is 14 units, okay, so in one operation you are reducing 2 units of, in one operation you are reducing 2 units of distance. Okay, so that means if you divide this 14 by 2, then you will get the total number of operations required to make them equal. Got it? I'll take different color pen here. Got the solution? 7 we got. Okay, so one more time I am explaining. Just see here. Understand the logic. Okay, so once you get this logic, then it becomes very easy. Okay, so this is 2, 6 and 12. Okay, so assume that this is P, Q and R. So to find out the number of distance, same whatever we calculated here, this we are putting in mathematical terms. That's it. Okay, so what we are doing is I am trying to calculate the total distance this smallest number has with other two numbers. That is what my intention is. Okay, so the smallest number has a distance with the second number. Okay, so distance 1 I am calculating. Okay, so it has 6 minus 2. It has 4 units distance. The difference, you can find out the gap between first number and the second number, because you need to fill the gap, then only they becomes equal. You should reduce that gap, then only they becomes equal. Yes or no? Okay, so the gap between first number and second number is 4 units. The gap between first number and third number is 12 minus 2. Okay, so which is equal to 10 here. Okay, that means the first number has a total gap. Okay, so total distance or total distance, you can say total gap, you can say. So it is 4 plus 10, 14. It has total 14 units of gap with other two numbers. Okay, so you know that in one operation, you are reducing the distance by 2 units. You are reducing the distance by 2 units. Okay, so then the total gap is 14 units. Okay, so to make this gap 0, then how many such operations are required? Like this, in one operation 2 units, in another operation 2 units, like this. If you perform, that means 14 by 2 if you perform. Okay, so then the number of operations required is total distance divided by 2 if you perform. Okay, so then it is nothing but 14 by 2. You get total 7 operations required to make them equal. Here we got that 7 operations. Let us apply this to our 117 example. Okay, so I am taking this 117 here. 117. Okay, so let me take that 117 here. Then let us work out for this, whether this rule works or not. Okay, so now you find out the distance between first number, second number, first number and third number. Okay, so distance 1 I am calculating. What is the distance 1? 1 minus 1, it is 0. Then distance 2 I am calculating. 7 minus 1, it is 6. Okay, so what is the total distance or total gap? Okay, so 6 plus 0, the total gap is 6 plus 0. Okay, then the number of operations required as total gap is, total distance is 6. Then in one operation you are reducing the gap by 2 units. Okay, so number of operations means 6 by 2 is nothing but 3. 3 operations we required. This we solved here. See, operation 1, operation 2, operation 3, we arrived at equal numbers 444. Okay, So that means even if now you can see here. So once you get this, this is the formula. What is that number where the numbers become equal? That also you can calculate. Okay, given a set of input numbers where the numbers become equal. Okay, so that also you can calculate by using this formula, because once you know this, okay, so you can find out where the numbers become equal by using this total distance. Okay, so example, see here, if it is 117, you want to know. Okay, so sometimes the question will be asked where the numbers, at what number all of them become equal. If that kind of question is asked, now you can see, so their initial sum is 9, no? Then you calculated number of operations required is 3. Okay, so then this becomes equal to 12. Okay, so which should be written as a multiple. This 12 should be a factor of 3, we said. Okay, so then 12 by 3 you do, it must be a factor of 3. The total distance should be a factor if they all of them are equal. Okay, so 12 by 3 you perform, then 4, that means at 4 all of them become equal. Okay, so 111 becomes a lastly 444. It becomes a 444. Okay, so to know 2 6, if you want to find out 2 6 12 where they become equal. Okay, so use this formula. S plus n is equal to total sum or total distance. Okay, so first try to calculate n value here. Okay, so how to calculate n value? What is s here? It is 2 plus 6 plus 12. Okay, so how much it is? 18 plus 2 20. It is nothing but 20. Initial sum is 20. Yes or no? Okay, so that means the number of operations required. Okay, so what is the number of operations required for this? You need to calculate. So how we calculated? Total distance divided by 2 if you perform. Okay, so then we will get this. So you need to calculate the distance between these two numbers. Yes or no? Okay, so pq are given. PQ are given. So you calculate the distance between distance 1. Okay, so that means distance between second number and first number. It is 6 minus 2. 6 minus 2 is 4. Then calculate the distance between last number and first number. 12 minus 2. It is nothing but 10. Okay, so what is the total distance? Total distance is 10 plus 4 is 14. Okay, so then the number of operations is 14 by 2. 14 by 2. Okay, so 14 by 2 is 7. Okay, so what is the formula for this? It is nothing but if you say that distance 1 is nothing but q minus p, you need to perform. Okay, so this is nothing but r minus p, you need to perform. So then total distance you will get the number of operations formula. Okay, so n can be written like this now. Okay, so it is q minus p plus r minus p divided by 2. You will get the number of operations. Once you get number of operations, okay, so where they become equal you want to calculate. Okay, so you got s value plus you got n value 7. Okay, so n value you find out, this s is 20 plus 7, then they become equal 27. You write this 27 as a multiple of 3, so 3 nines are 27. Okay, so this is the target value. Okay, so the target value is 9. That means the numbers 2 6 12 finally they become 999. They become 999. Got it? Now we'll take a different test case which we have not seen. For example, I have a test case like this: 1 5 and 9. 1 5 and 9. Okay, so can you tell me the target value for this? Type in the chat. Take 2 minutes of time and type in the chat. Number of operations required, you type n is equal to how much, and also what is the target value. These two values you type in the chart. Take 1 minute of time and calculate. For this combination 159, okay, so number of operations required how much and what is the target value, that means at which number all of them become equal. Yes, anyone calculated? Just post your answers in the chat. Right, still if you are in dilemma, okay, so now we'll take a new test case and understand this, how we can calculate the number of operation and what is the target value. Actually this target value is not required for us, okay, but for our uh, clarification, okay, so we'll find out, and manually you can also check this whether we can make equal to this target value or not. Okay, so the very first thing is what you need to do, you need to calculate the number of operations. Okay, so if this is p q r values, then what is the formula for number of operations? Q minus p plus this is the total distance, okay, by 2. If you perform, then you will get the number of operations. So q minus p, okay, so it is nothing but q minus p plus r minus p divided by 2. Why 2? Because in one operation you are reducing the distance or gap by 2, okay, that's why you are dividing with the 2. So this is nothing but q minus p, it is nothing but 5 minus 1 plus r minus p 9 minus 1 divided by 2, okay, so which is equal to 4 plus 8 by 2, okay, so 12 by 2 which is equal to 6, okay, so 6 operations are required to make them equal, to make them equal. Okay, so then what is the target value? To get the target value, you find out s plus n. Okay, so initially s how much here? 9 plus 1, 10 plus 5, 15. Okay, so 15 plus 6 you got. Okay, so it is nothing but 21. So you can write as a multiple of 3 here. Okay, so 3 7 is 21. Now this is your target value. Target value is 7 here. That means 159 becomes 777. Okay, so how they become 777? Now let us write here. Okay, so initially it is 1, 5 and 9. Now I increment this by 1. I increment this by 1. Shall we take a new page? Yes, 1 5 9. Okay, so now I increment this by 1, I increment this by 1, I decrement this by 1, so this becomes 2, this becomes 6, this becomes 8. Okay, so again I increment this by 1, I increment this by 1, then I decrement this by 1. Okay, so this becomes a 377. Okay, so again I increment, this is operation 1, this is operation 2. Okay, so I increment this operation 3 I am performing. Then I increment this by 1. Then I decrement this by 1. Okay, so it becomes a 4, 8, 6. Okay, so then what I can do now, I can increment this by 1. Okay, then I can increment this by 1. Then I can decrement this by 1. So it becomes a 577. Operation 4 this is. Okay, so then what I can do is I can increment this by 1, it becomes a 6. Okay, then I can decrement this by 1, this becomes 6. Then I can increment this by 1, it becomes a 8. Okay, so this is operation 5 here. Then what I can do, operation 6, I can increment this by 1, I can increment this by 1, I can decrement this by 1. Now became 777. Got it? Okay, so in 6 operations, we are making 159 as a 777. Okay, so mathematically, this is what we arrived at. This is the target value we got. Okay, number of operations n value we got as a 6 here. Got it? Now we want to convert this. Now see, there is nowhere this process is required. This is only for our clarification. We are checking this. Okay, but no need to calculate all these things in program. Okay, so in program you can just use these formulas. You can use this formula to calculate the number of operations required. Just it is just the implementation of a simple formula. Okay, the very first thing is parity check. If it passes parity check, then you can use this formula to print the number of operations required for this. Okay, so shall we write program for this? Initially the problem seems to be simple. Okay, but if you understand the logic, okay, so then again it becomes easy. Finally now also it becomes simple. Okay, just it is implementation of this formula, but arriving at this formula is very important. That means identifying this logic is very important here. Got it? Okay, so we'll write the code for this. So what we can do is we can read the input properly. That is also very important. Okay, so you should read the input properly, otherwise your program uh, may fail. Okay, your program may fail in making all the three numbers equal. Okay, so for that what you need to do is you should read the input values properly. That we should understand. Okay, so let us write code for this. So here is my main code. Okay, so just like I am writing my main code, assume that. Okay, so here what I do is I directly call the function. Okay, so find. Okay, so find what we need to find, minimum operations. Okay, I call the function name as a find minimum operations. I'm calling this function. Just I'm calling the function in the main code. Okay, so here we'll define the function called as a find minimum operations. This function we will define. Okay, so just I'm trying to show you how to write a function. Okay, so everything you can write in the main itself if you require. Okay, right. Another important thing is how the test cases are. Your test cases are given like this. 4 is the number of test cases, then followed by these test cases 1, 2, 3, 4, 4, 4. Okay, 3, 2, 6, and then say 1, 1, 7. Like this, the input is given. Okay, so if you read this input by using input function, it becomes slow. It becomes slow. Okay, so for this, what you need to do is you should use the sys module. So that's why you need to import the sys module. Import the sys module in Python. This is system related functions available here. Okay, so all the standard input output related functions available. You can read this entire input in one go. Okay, if you use input function, okay, it reads line by line. Every time it has to give an interrupt to the operating system, which makes your program slow. Okay, so if you read the entire input in one operation, one go, okay, so then afterwards you can get these values from a variable inside your program. Okay, so which makes your program runs faster. Okay, so how to read that there is a function called as a, okay, so in this is your input data, okay, so read this input by using a sys dot, because it is available in the standard input, okay, so stdin dot, okay, so there is a function called as a read, okay, so it reads entire input available on the console in one operation, okay, so then say split, you can split this entire input, okay, so what it does is it splits the read, will read the entire input as a string, okay, it reads this entire thing as a single string, okay, 4 1 2 3 reads as a single string, then this split function splits this into individual strings and returns a list here, returns a list here, so your input data looks like this, okay, so I write your input data variable here, okay, so this is your input data variable, how it looks like, okay, so it looks like as a list here, okay, so containing all the values, 4 is one value, then 1 is another value, 2 is another value, 3 is another value, okay, so like this all of them becomes elements in the list. That means entire input is available in one read operation and is available in the list. Getting the values from the list is also very easy. This is how your input data contains this. Okay, so the first value is nothing but the number of test cases. The first value is nothing but the number of test cases. Okay, so here you need to check. Okay, so if it is giving reading properly, okay, so you should test, otherwise generally in online platforms it is not required, okay, so this you can use here. If not input, that means if some of these functions fails, read function fails, nothing comes into this input data, then input data contains an empty list here, okay, so then you should check here, if not input data, that means if input data is empty, you haven't read any values into this, you cannot do processing, so simply you return. Okay, so otherwise now we will read the first number, okay, so your first number is available at, this is list indexing starts with 0 1 2 3 4 5 like this, okay, so input data of 0 is nothing but the number of test cases that we will read into a variable called as a t here, okay, so t is equal to, and it is in the form of a, it is in the form of a string, okay, so you need to convert that into integer, so pass it to, so where it is available, from input data of 0. It is available at input data of 0. Okay, so the first value it reads, this 4 it reads here, this 4 it reads, and that will be stored in a t, because you have to repeat a loop for reading each test case. For that you need to store this one, okay, so then where all others are stored after the first index, that means the first value is available at index 1 2 3, okay, that means the first test case is available at index 1 2 and 3, okay, then the next test case is available at index okay 4 5 6 like this, next index, next test case is available, that means every test case should be incremented by 3 to get the new test case, okay, so what we do is we read all this, okay, so we'll start at index, I'm taking a index of the test case where it is starting, the first test case starts at index 1, okay, so then what we required here, so we need to read each test case here, okay, so for that what we do is we use a for loop here, for this is variable is not required, when variable is not required you can write like this, for I in a range of a t. Okay, so this t contains 4 here, okay, so 0 1, that means the loop repeats 4 times because you need to process the 4 test cases here, yes or no, so the loop repeats. Now read the first test case, this is your first test case, and read these 3 into 3 variables, okay, so how you can read this, the first value you read into P. Okay, so it is nothing but int of input data. It is available at input data of index. Input data of index. Okay, so index is nothing but input data of 1. Input data of 1 means it gets the first value. Okay, so 1 it gets. Okay, that is P value. Similarly, you get the Q value. You want to use capital letters or small letters, whatever you want, you can use. Okay, so Q is nothing but int of input underscore data of. Okay, so what you do is, it is available at index 2 no, so one index plus 1 you add. Okay, so don't increment the index just now. Okay, so you just add index plus 1. Okay, so it becomes 1 plus 1 2. Input data of 2 means it gets the second value. Okay, so this value 2 it gets into Q. Okay, so then read the R value, then int of input underscore data of index plus 2. Index plus 2. Okay, so 1 plus 2 is 3. So it is available at 3. This comes into R. So now you got the values P, Q and R values like 1, 2, 3 you got. Okay, so once you get the first test case, then immediately what you need to do, the index. Okay, so where the second test case will present, if it is 1 2 3, then next test case will present at index 4. So that's why you increment the index by 3. So that's, you say index plus is equal to 3. Every time you increment the index by 3. This is the best way of writing this. Okay, so I'm just removing this main code here so that we can complete this function here itself. Now this is a reading of the three values. Once we got the three values, what you need to do, the very first thing is you perform the parity check. You perform the parity check. If it passes parity check, then only you should go for finding the number of test cases. Okay, so how you can perform the parity check? You can perform the parity check like this. That means all should be even numbers or all should be odd numbers. Yes or no? Okay, so then you can check here. Okay, so if inside the loop only. Okay, so if P mod 2 should be equals to Q mod 2 should be equals to R mod 2 or mod 2. Okay, so that means if all of them are having the same parity, if all of them are having the same parity. Okay, so for example, if they are even, then all of them will have this value becomes 0, this becomes 0, this also becomes a 0. That means all of them are having the same parity. Yes or no? So in such case, what you need to do, if they are not satisfying the parity, okay, so that means you should use not here. If not, okay, so then you should return directly -1 you should return. Okay, so you return a -1 from here. Okay, so since we are not returning here, since we are not returning so what we can do is, if you want to directly return that, you can return. Okay, so but the final answer should be 4 answers you should return at a time for all the test cases. Yes or no? Okay, so that's why what we do is, instead of returning each value, okay, so here we define a variable called as a something like a results variable we will define. Because we want to store all the results in a one variable. Okay, so we define a variable called as a results. Okay, so initially we define an empty list here. Okay, so then we append -1 to this results here. Okay, so then once they are not satisfying the parity, okay, so what you can do is, okay, so you can just say that results dot append, results dot append, then say -1. Okay, so you add -1 as a string. Okay, so this is parity check. This is parity check. What happens here? This you should understand here. For this example, 159, what happens? We should understand here. Okay, so whether it is passing the parity check or not. Okay, now we'll see here. P value is 1, no? 1 mod 2. Okay, so when you say 1 mod 2, what you will get here? You will get the remainder as 1 here. This returns the remainder 1. Okay, then Q mod 2. Q mod 2, 5 mod 2. Okay, so you get the remainder as a 1. Okay, then 9 mod 2, you get the remainder as a 1 here. Okay, so since all of them are equal, okay, so 1 is equal to 1 is equal to 1, yes, true. True you will get here. Okay, so then means within the parenthesis you will get true. Not true. Not true means it becomes false. Okay, so it becomes false means this statement is not executed. That indicates that it has passed the parity check. It has passed the parity check. If any one of them, okay, like in our other test case, if it is 3 2 6, we will see. Okay, so it is not satisfying the parity check. That's why the answer is -1 for this. Okay, now we will test here. So 3 mod 2, what you will get? 1. Okay, is it equals to 2 mod 2, what you will get? 0. Okay, is it equals to, okay, so 6 mod 2, what you will get? 0. So 1 is equal to 0. No, false you will get here. Okay, so once you get false, it won't go to next one. So not false, not false becomes true. Okay, if true, when if true, then it executes this statement, results dot append to -1. So -1 will be stored in the results list here. Okay, so that means it is not satisfying the parity check. Okay, so it is failing with the parity. That's why -1 will be appended here. -1 will be appended here. Okay, so otherwise now you can use the formula to calculate this. Okay, so else, that means if it is satisfying the parity check, then it comes to else part here. Okay, so in else part, what you can do, you can calculate the number of operations here. Okay, so then you can calculate number of operations required is equal to, okay, so it is just like a q minus p. Yes or no? Okay, so q minus p, you have used capital letters, no? Q minus p plus r minus p. Okay, so then whole divided by 2. Okay, so it should be integer division, whole divided by 2. Okay, so then you will get this number of operations value. This you append to results. Then you can say results dot append, results dot append. Okay, so then you will get an integer number. You convert this into a string. Okay, then say operations will be converted into string and added to results, so that you can return the entire string in one go. Got it? So this is for that first test case. Inside the loop, we read the first test case, PQR values here we read. Okay, so just see here. We read the PQR values for the first test case, you will get here. Okay, then you are checking here. Okay, but here, before this, what you need to do is, if to apply this formula, okay, to apply this formula, then the PQR values must be in sorted order. The PQR values must be in a sorted order. Okay, so for that, what you need to do is, before you enter into the for loop, okay, or inside the for loop you are reading, no? Okay, so before you perform the parity check here. Okay, so what you can do is you can arrange them in sorted order. Okay, so this line I am writing here. Okay, so you arrange them in sorted order. For that we have a function called as a sorted. We have a function called as a sorted in Python. Okay, because if you arrange them in sorted order, P becomes the smallest one, R becomes the largest one. Then only this Q minus P plus R minus P formula is applicable. Otherwise, you will get with wrong answer. Okay, so that's why you should arrange them in sorted order. Okay, so what you will do is use arrange them in sorted order. P comma Q comma R is equal to, use the function called as sorted. Okay, then pass this list. Okay, so PQR, old PQR will be sorted, and that returns the three values. They will be caught in a PQR values. Now you can perform the parity check here. This is working fine here. Okay, so you can use try catch back to test if your program raising any index errors or not. Okay, so once you got this, for each test case you will get the results appended to this one. Okay, so how your results array looks like, your results array looks like this. It looks like this. Okay, for example, for the first test case, what you will get, you will get -1 as a string. Okay, for the second test case, what you will get, 0 as a string. For the third test case, what you will get, -1 as a string. For the fourth test case, what you will get, 3 as a string. This is how your results array looks like. Results array looks like. Okay, so that means after processing all the test cases, your results array looks like this. Okay, so what you need to do is you need to convert this results array, but we want the output to be displayed like this: -1 0 -1 and 3. In next line it should be displayed. Okay, so what you can do is you make this results array, it is like this, no, -1 string, 0 as a string, then -1 as a string, then 3 as a string. Okay, so what we do is we write onto the output. Okay, so if you use a for loop here, okay, then it takes a time by using the print function. Okay, so every time print function, when you call print function, what it does is it takes a value from this, then adds new line character to this, adds new line character. Okay, that means from your results array it takes -1, the string it takes, then converts this into a number. Okay, then adds new line to that. Okay, then it prints. So for this the time is wasted here. Okay, so you want all of them to be printed in one operation, one go. You want to print out all of them in this format. Okay, so for that you can use a write function. Write is very fast compared to print function. Remember this. Okay, so what I do is I'll just use the write function to write onto the standard output. Okay, so after coming out from the loop, just you write here sys dot. Now you can use std out, standard output. You want to write onto the standard output. Okay, so we'll say write. We'll say write. Okay, so but what you need to do, you need to send the string to this one. Okay, so for that what we do is we'll pass the string. So we got the list, the final list, results list is in this format. The final results list we got in this format. Okay, containing these 4, but we want them to be printed on the screen. Okay, so what we can do is we can add a new line. Okay, we add a new line to them. Okay, so then say dot, you can use the join function. Okay, so join these values with new line here. Okay, so new line dot join, then to this now you pass your results. Okay, so then finally you add another new line, because after this 3, the next one to be printed. Okay, so when this is written on the screen. Okay, so when you perform this join operation, okay, so your uh, from results, okay, after performing the join, it looks like this. Okay, so new line, -1, okay, so then new line, 0, then new line, -1, new line. That means all values will be joined with the new line characters. Okay, so -1 new line, then 3 new line. Okay, and this string, when it is written onto the std standard output by using this write function. Okay, so now it prints like this. First, in the next line, because already input is present, some input is present on the uh, standard output. Okay, so you have given your input on the console, no? So in the next line your output should be printed. That's why we added first new line first here. Okay, so -1 will be printed, then 0 will be printed in the new line, -1 will be printed in the new line, 3 will be printed in the next line. After that you will have your cursor will be waiting here. This is how you can print your results. Okay, so this string will be printed in this format. Okay, so in required format, now you are printing the output. Okay, if you print this from this results, okay, no doubt you can print from the results list. Okay, but using results list, you should use print function. Okay, so the disadvantage with the print function is every time it gives an interrupt to operating system. Okay, so asking for a value and printing it, appending it with new line. Okay, so all these things happens which makes your program slow. Assume that your results list contains 1 lakh entries. You can just imagine how much time it takes for your print. Okay, so then your program gets a TLE error. That means your program takes longer than the allotted time. Then it gets TLE error, time limit exceeded error. So if you use such small tips in your program, okay, so you can uh, overcome such errors. That means your program passes this TLE, performs all the operations within the allotted time. Got it? So shall we execute this? Any doubt in this code? Now see, we have just used this formula to find out number of operations here. Okay, so using this formula, now nowhere we have calculated all these things. Okay, so this stuff we have not did in our program. It is not required also. We required only the number of operations, how many operations required for performing these things. Okay, so that is what we required, right? So let us execute this. Okay, so I typed this code. Okay, so in the online compiler. Okay, so since online compiler doesn't support the sys module, okay, so what I do is I open IDLE and I'll show you the execution part in the IDLE. Okay, in online compiler sys module is not supported. Okay, so let us go to IDLE. So let me share the screen to you. Got it? Right, this is the code, okay, so which we discussed, find minimum operations, okay, so I'm reading the entire data by using the sysin stdin dot read split function, okay, so then I'm reading the first number of test cases here, okay, so then you can index or pointer, whatever we want to, you can name it, okay, so then I'm reading the three numbers, incrementing the pointer by 3, then I'm sorting the three numbers, storing in pqr, okay, so you can also do parity check in this way, okay, so p mod 2, okay, so this is what we did, or other way is this way also you can do, this is faster compared to this, because every time it needs to find the uh, reminder and check whether all reminders are equal or not. Instead of this, then the distance between the first two numbers and the last two numbers, if they okay, so are even, then you can say that the parity is satisfied, okay, otherwise you can just append -1 to the results, okay, so then finally you can calculate number of operations and add the result to results list, that's it, and finally write onto the standard output, that's it, okay, so let us run this code. Yeah, unexpected indent where, okay, this I think I need to, okay, so this one I'll remove here. Find min operations, okay, so if you see, I got a name error here, okay, because find min operation spelling I have written wrong here, okay, so this find min operations I need to correct this, so let me correct this. So in the main I have written as a operations spelling as a wrong, okay, so save this again, I run the code, okay, so now it is asking for the input. Now it is waiting for the input, okay, so what we'll do is we'll give the input, we enter the input as per our problem statement. So number of test cases are 4, okay, so then first test case is 1 2 3, then the second test case is 4 4 4, then the third test case is through 3 2 6, and the fourth one is 1 1 and 7, okay, so here you need to use control D to stop your input, okay, so from the console if you want to stop your input you should enter control D. Now you can see the output here, -1 0 -1 and 3, okay, so in the given problem these are the test cases provided, okay, and these are the answers which are same as the problem statement, okay, so let us try with our own test cases like 159 and 2612 we worked out now, okay, so we'll try to enter those two test cases also, and we will check whether we get correct answer or not from our problem, okay, so I run this code once again and I'll show you those test cases also, okay, So let us run the code once again. Now this time what I do is I'll just add two extra test cases. Okay, so for that now we'll use that number of test cases as a 6 here. Okay, then we'll enter those two also. Okay, so 2. Okay, so 2, 6, 12 will enter here. Then 1, 5, 9. Okay, so these two also will enter. Now total 6 test cases we entered. Then if I press Control D, now you can see. So for 2, 6, 12, for 2, 6, 12, we got the number of operations as a 7. Okay, so which is same. And for 1, 5, 9, we got the number of operations as a 6. Okay, which we can confirm from our examples. Which we can confirm from these examples. Now see for 159, the number of operations are, you can see here, for this input, the number of operations are 6 here. Okay. Similarly, for this 2, 6, 12. Okay. So 2, 6, 12, we worked out, see number of operations required are 7 here. Number of operations required are 7. This is the answer which we got. Okay, so if we have any other test case which I need to test, just type in the chat and we will test that. Okay, so the first thing is it should pass the parity check. Okay, so in the given input, now you can see the first and third are not passing the parity checks. Okay, so that's why we printed -1 in such case. Okay, look at the output carefully. So here this 1, 2, 3. Okay, so as having different parity here, 3, 2, 6 are also having different parity here. Okay, so they failed. That's why the output is -1 here. Output is -1 for these two test cases. Directly -1 it is printing here for these test cases. You can observe here, this is -1, this is -1 for these two test cases, 3 to 6 with different parity. All should have either even parity or all should have either odd parity. Then only you can make them equal. Otherwise, it is not possible. If you do any number of operations, they never become equal. That is the meaning of this -1, -1. So even afterwards, if you get any test case, typical test case, okay, so where the program may malfunction, if you find such test case, you can type the test cases in the chat box and we will try those test cases against our code. So hope you understood the problem. If you have any queries, quickly you can type in the chat. So friends, if you found this solution useful and helpful to you, and if you like the way the problem is solved, and if you understand the logic behind such kind of questions. Okay, parity check is very very important in such kind of questions. So please like and share this video. And if you are new to my channel, please subscribe to the channel and also turn on the bell icon for more such coding updates, programming solutions. And if you have any queries related to TCS NQT coding questions or any other coding doubts, if you have, you can post your doubts in the comment box of this video. I will send you answers once I look at those comments. So thank you one and all. So in the next video, we will solve one more such question. Question number 4 asked on March 15, 2025. In our next video, we will solve that question. So thank you one and all. Happy coding, happy learning.